crypto as a technology, it's an enabling technology to build what we've described here, essentially, to take away that need for a centralized party to make certain decisions and to check work and things like that. In order to take that away, you have to have lots of technology that's kind of at the machine learning level. It does cryptographic checks and game theoretic checks and things, but you also have to coordinate a lot of parties who have different incentives. So there's a big game theoretic challenge over the coordination of those people, and that can be solved via some of the like cryptocurrency technologies. So you require somebody to stake a bond in order to provide their services as a compute supplier. And then when they're doing the work, if malicious behavior is detected by other parties, then that bond can be sacrificed to pay out other parties. You end up with redundancy in the protocol there, where you could keep chaining the sacrifice of a bond when somebody hasn't done the work correctly, which pays for somebody else to do the work, but then their bond could be sacrificed, and the whole thing eventually settles out. But what you get there is tons of micropayments that all settle out at the end with loads of different parties involved, which if you try and do that purely technologically with our existing like fiat payment system, it'll be an absolute nightmare / impossible. So
/ impossible. Welcome back to What Kind of Internet Do You Want? I'm Amy James, and today we are speaking with Ben Fielding and Harry Grieve, the co-founders of Gensyn. I'm super excited to talk with you guys today. So really glad to have you on the show. Thank you so much for making the time.
Yeah, thanks for having us, Amy. Really appreciate it.
So I just wanted to get started. For people who don't know you, if you guys could just give us a brief background on who you are and why you work in Web3. Do you want to get started, Ben?
Sure. So I'm Ben, as Amy said, one of the co-founders of Gensyn. My background is outside of Web3. It's in the machine learning space originally. So I started out doing a PhD in machine learning focused on neural architecture search within deep learning, which is a very computationally expensive kind of niche area of deep learning specifically, where you're searching for the optimal structure of deep neural architectures, which are the models that kind of do most of the AI things that we see today. So yeah, I kind of started technically there and then moved into the startup space during and after my PhD, where I co-founded a startup around data privacy and data sovereignty. And that was where I first kind of got exposed to the Web3 space, because a lot of the data sovereignty thinking at the time was centered around how can we use kind of like non-centralized techniques and like technologies to solve some of the problems that we have in digital identity and kind of data ownership, data control, all those areas. I didn't actually explore any of those techniques at the time. I played around with them and then went straight into building the business side of data ownership, which was GDPR compliance software. Kind of ran that startup for a couple of years until realized that the regulators weren't going to push very hard on that, and the world wasn't quite ready for self-sovereign data management yet. I think I still strongly believe in that, but I think it'll come from a Web3 protocol, and hopefully someone listening to this is building that, and I'd like to try it out. But yeah, after that startup, I joined the Entrepreneur First Accelerator in London, which is where I met Harry, and we started Gensyn nearly 4 years ago now, which is like a crazy amount of time.
Okay, awesome. That's interesting with the GDPR thing, because yeah, that whole thing has just been such a mess in some ways. Harry, how about you?
So my background's also in machine learning. I think something kind of unique about Ben and I's journey is we both came from outside of crypto, as it were, and into it. My background's in applied machine learning. So after doing my postgrad, which is a combination of statistics and economics and politics, basically econometrics, I got introduced to machine learning in the lab I was in, and immediately thought, this is transformational. This is going to be the next kind of major unlock for society, and promptly joined a applied machine learning startup in London. I led their data research team for approximately 3 years, predicting building fire risk and natural catastrophe risk using alternative data sets and very kind of narrow statistical machine learning models. So we were basically trying to predict, given things as unusual as like your kind of distance from a fire hydrant, or your proximity to like a kind of overhanging tree, from satellite imagery, whether or not your house was going to catch on fire or catch on fire worse than your neighbors. It kind of taught me kind of two things. Firstly, this technology was going to be applied not just in this narrow domain, but everywhere. Ultimately, I saw the power of it. Narrowly, generally, it was going to be very big. And secondly, that the major kind of bottleneck would either be around data or compute, which is quite a broad kind of brushstroke to make. Essentially, models are trained using vast amounts of data, but the more data you use and the bigger the model, typically the more compute you use. Joined Entrepreneur First straight out of that startup where I met Ben, and we really kind of connected on kind of like three different dimensions. Firstly, we both wanted to build a very large machine learning infrastructure system because it was clear that connecting everything up from either a data or a compute perspective would be the unlock that kind of took machine learning in general. The second thing was we had a very kind of strong, I guess, like censorship resistance, kind of cypherpunk style, I guess, like, philosophical
Awesome.
affiliation to one another. So one of the first things that we bonded over was Edward Snowden's autobiography, which was interesting because we ended up actually speaking to Edward Snowden at a conference, as part of Gensyn, which was really cool. And thirdly, something which I think's possibly underestimated in co-founding pairs, we have a shared sense of humor. Perhaps it's from being from the north of the UK, but it certainly helps during the various kind of funny moments in the crypto markets.
Absolutely, absolutely. I've worked with my husband now for, oh my gosh, more than 10 years in the space. And that sense of humor, especially having a somewhat dark sense of humor, I think is quite necessary sometimes in this industry. Okay, well, awesome. I was really looking forward to today's conversation because you guys are at this really interesting intersection of crypto and AI. And I think that they both need each other. Crypto needs AI needs crypto. I've felt personally really frustrated working in crypto now for over 10 years that we haven't gotten further along in terms of easy to use tools, in terms of getting that last mile to end users. And I think that AI could be the missing component that could really accelerate things. So I'm hopeful, I'm optimistic about that. So, at a high level, how would you explain your project to somebody who's not technical? We'll get into the technical details next, but just give us kind of a general overview. And whoever wants to take these questions, you guys can just kind of decide between yourselves.
Sure, maybe I can go first, and then Harry can kind of add anything and see if we differ in answer. But I think the easiest way of explaining Gensyn is essentially a marketplace over all of the machine learning capable compute hardware in the world, so that it can be used by anyone to train a machine learning model. So right now, those users, if you did want to train a machine learning model, you would have to find somebody who's going to rent you the hardware required to train it. You might be able to buy that hardware yourself, but if you can't, for whatever reason, you can't put the capital up front, you'll probably rent it from a major cloud provider like Google or Amazon or Microsoft, or maybe kind of one of the smaller providers who can give you access to some compute, but not as much as those big providers. Gensyn's a kind of very, very wide distribution of any device in the world. So any device that can do machine learning computations can be connected up and then can just be used by somebody else in the world. So it kind of breaks down that which company do I go for, and changes it into this, okay, someone in the world has hardware that I can use and I need to be able to have a contract with that person. In the traditional world, you would have a legal contract, you would have like customer service, you'd have infrastructure that was built there so that you could actually get your models to the device and things like that. The Gensyn protocol essentially replaces all of that with technology, so that via the kind of typical infrastructure ways, we can get the models to the user, to the compute itself. And instead of having contracts and legal agreements and things, we have essentially smart contracts and everything settled at the consensus of the suppliers themselves, rather than having this person sat in the middle saying, you can have this relationship, you can't, you can send this model over here, you can't, etc. It's all kind of done the collective sort of governance of everyone together.
Gotcha. So you guys are definitely more of a product for builders, not necessarily for end users in that way.
Yeah, definitely more for builders. The long-term view that we have of Gensyn is as a kind of as a protocol in the Web 1 sense, where it's a fundamental underlying technology that just connects up devices. So you can think of us like TCP/IP or like HTTP or something. We just provide the rails for these connections to happen. And those rails couldn't exist before crypto as a technology, because you had to have somebody sat in the middle that could enforce if somebody doesn't do the work that was sent to them, or if somebody sends malicious work in some way. It would have to be decided by that person that sat in the center, basically. Uh, with crypto technologies, we don't have to have that anymore. Everyone can kind of do it themselves and govern it in a decentralized way, which means we can build this big network and allow those connections to happen. So yeah, it's kind of like a traditional Web 1 protocol where it just connects everything up, but then with all the flair of Web 3, where we can handle all the contracts and legals and things purely through technology, which we think is, for a lot of industries, is the future of how we'll do this, particularly for resource incentivization, where you've got this core resource that somebody needs to provide. And previously, you would have to have somebody who would like coordinate the provision of that resource and take their cut, and then would be incentivized to expand that cut. And then you'd end up with undercutting, and the whole cycle repeats. We don't need to have that in this new world, and we'd like to build the machine learning compute version of that. There'll be many other versions, and it makes a lot of sense to go narrow. We're big believers in the thin protocol hypothesis, that you go very, very narrow, very, very specific in what you do, and everything else will kind of get forked away until you end up with these hyper precise, very efficient protocols that just do one thing really, really well.
I completely agree with that thinking. I think that what some people seem to miss is that you can't have two priorities, right? You really have to optimize for whatever it is that you're optimizing for. And so, you can't have be very high speed and also maybe take a lot of, process a lot of data, or a lot of like you kind of can't have like high speed transactions and then also have a huge amount of data or something like that. Like there's just these different ways that people are trying to bundle protocols together and have them do lots of different things, and that doesn't, over time, once we're talking about things that are working at scale, they have to really, like you're saying, optimize for one specific thing. So that makes a lot of sense. Harry, do you want to add anything?
I mean, I think it's completely flush with my thinking. I think for some of the listeners who want a more kind of like bricks and mortar analog, you could think of it similar to hotels, in the sense that hotels used to be this kind of thing where there'd only be certain kind of licenses granted to large hotels and towns. As a user, you're like, I want to sleep somewhere tonight, I don't have a house here, go to a hotel. Airbnb came along and basically said, well, there's this constrained supply here where, the building has to be like a hotel, has to look like a hotel, has to pass all these checks. That's inefficient because lots of people have spare bedrooms, etc., and people can stay in there. And then, as a consequence, it increases the stock of available kind of rooms, and theoretically, at least, depresses the price of a room rental in a town. I compare us, to that. We allow access to a broader spectrum of computational devices. However, we have the added kicker, unlike Airbnb, of not having a central party which extracts a margin. So the kind of crypto protocol, and the reason that Ben and I kind of walked the long path from machine learning into crypto, provides us with kind of two things. One, essentially the removal of margin. There's no middleman. There's no one in the middle. It's a peer-to-peer transaction, and therefore the price is lower. And number two, the trust component. You have the ability to kind of connect together all these devices in a trustless setting without kind of having to have that trust with a kind of third party, which is usually solved by a middleman doing kind of KYC checks, etc., which also in fact increase the price. So yeah, the price and scale benefits that you get from crypto are the kind of main reasons.
Yeah, okay. That makes a lot of sense. Let's get into some of the technical details that the nerds among us will appreciate. Um, can you kind of get into some of the details of, so okay, well, let me just start with the top question for myself. Like when I think about the different kind of DePIN protocols, and I would try to compare you to them, I would say like a cache, you're renting like the bare metal. There's not um a specific protocol that you're renting from a cache that you're going to, specialize in some sort of thing. Whereas with something like LivePeer, it's a protocol for, they're focusing on video transcoding right now, and so you would use that to transcode video. And so Gensyn, it sounds like is specifically for machine learning. And please tell me if I'm getting this wrong. Are there aspects of your protocol that are supportive of machine learning in that way? Is it a package that you're creating for developers to use? How does that how is it different than
Yeah.
maybe a cache where you're renting, the bare metal kind of thing?
So, so I guess to answer the second part of your question, like exactly kind of what is it? It's a protocol which very inexpensively verifies a series of state-dependent graph computations. That's the absolute nuts and bolts way you could describe it. What a neural network is, for the listeners not familiar with machine learning, is basically a series of layers of computations through which data is passed, and then there's a kind of derivative function applied going back across the various layers, multiple hundreds, maybe thousands of times in some cases. The kind of result of that is you basically have to traverse this graph in a state dependent way multiple times. You can use a protocol like a cache for that. I used a cache earlier today. I was playing around with it, define an SDL, deploy it on a GPU, pay for it out the cache wallet, you bid on it. What you kind of don't get there is you don't get a verification system, so you don't know if the hardware that you're trading on is necessarily correct. It also uses a kind of reputation system for scoring hardware, and currently there's also a kind of audit functionality where the cache team will audit various devices to make sure they're good. I think a cache is a great protocol. What we do is distinct in the sense that we only do machine learning computation. So we only do those graph computations. Currently, we only do it for training, and we do it at a limited scale. Usually, if you require reputation-based systems, you struggle with scaling because the Byzantine fault tolerance, basically the ability to attack the network using, fake accounts in the civil attack sense, gets too easy. It gets too cheap to do. So we enable that huge scale. Because we're very specialized to just doing the machine learning verification, kind of graph computation, the price is very low as well. I don't know, Ben, if you would add anything to that.
I'd probably just emphasize how important the verification part is. That's the big problem in building anything like this. You can kind of build a marketplace over a resource just by providing the distribution. So providing some way of getting a computation to the device and then getting the results back. But that's only half of the problem. The other half is if I allow this network to get the largest it could possibly be, I will have to allow completely unknown parties to join the network as suppliers. And it's being able to trust those unknown parties that makes this a difficult problem. And verification is just how you do that. Verification of general purpose compute is a really hard problem because there's a lot of things you can do in general purpose compute. It's basically what Ethereum solves, but Ethereum solves it by having a lot of people rerun the computation essentially, which is one way to do it. But for machine learning computations, you don't have that luxury. They're very large. Like Harry said, they're state dependent. They're typically non-deterministic, which means rerunning them doesn't get you the same results, which makes it very, very hard. So you have to find different ways to get around it. But in finding those ways, you can exploit certain things about the type of computation. So you narrow the space by only focusing on machine learning computations, which lets you do things that wouldn't work for general purpose computation, make it more efficient, and then solve the problem just for that. And it's similar to what LivePeer have done for video transcoding. They've gone super specific. There'll be things that they do within the protocol that they couldn't do if they were doing some other computational task. And that's the approach that Gensyn takes. So we only focus on machine learning training itself, so the forward and backward passes of neural networks. But in doing that, we do a lot of matrix multiplications. There's things you can do with those matrix multiplications to verify them quite efficiently that you wouldn't be able to do if you had to call out and do a different operation essentially. And so yeah, I think like you said before, a cache does that general purpose computation and they do the distribution, but then when it comes to verification, I think they sort of pass that off onto somebody else. So the end user is sort of responsible for their own verification, which is an interesting way to do it. But for machine learning specifically, we figure the verification should be handled at the protocol stage so that the user doesn't need to somehow bring lots of kind of ways of checking their own computation. They just want to do the computation. And yeah, we kind of focus on that.
Okay, that makes sense. I've heard you speak in other interviews about this problem of deterministic versus probabilistic, and then using this, checking them with hashes, and how you can you guys talk more about that? And is that, have you solved that problem now, or is it something that you're still working on?
Sure. So really, for the listeners, determinism versus kind of non-determinism means that if you run the same computation on the same device, or maybe on a different device in the reproducibility sense, do you get the same result? And for the user at like the application level, a lot of the time it looks like the same result, like if 1 + 1 = 2. But if you go really deep down into the code, that one and one being added together might actually be kind of, very long floating point numbers being rounded up, and they actually might be slightly different. The issue comes here from how you optimize GPUs to, or accelerate them in order to make the computations execute faster. And typically, it removes some of the precision in what you're doing, because you're doing a floating points and not integers. There's really like 4 levels to it. So like at the highest level, the framework level, when you're training a neural network, sometimes it's just non-deterministic. You might have to randomly instantiate the neural network with random numbers to weights to start it off. That comes from a random seed, which is usually set on the clock time of the CPU. But like, if you rerun it later, then you get different weights and all the hashes. Remembering, of course, that hash, if it's wrong by 1 bit, the whole hash changes. So you have to be bitwise reproducible. So that's a problem there. You go 1 level down, you've got the kind of system level settings. So for example, if you have like a different, operating system version, a different, Linux version or something, that can also kind of cause sort of funny things like hijinks with respect to non-determinism. You go 1 level lower, you're on the GPU. On the GPU itself, the way that the kernels execute the functions, or rather the computations, can actually be non-deterministic. So there's various ways that you can set the GPU to run deterministically, but then there are some kind of functions which it runs. So for example, convolutional computations, which are common in vision networks, neural networks, they typically run in a way which is much harder to make deterministic. So sometimes that involves rewriting the kernels themselves to make them deterministic. I mean, if you go really low down on the physical, like plates, like the memory plates inside the GPU, if they get hit with cosmic radiation, sometimes that can cause a bit flip. So you have things like error correcting code, which are in there in order to to put in some redundancy to make sure we do the computations right. And what altitude you have the GPU at affects its likelihood of getting the radiation. It's a complex problem,
Wow.
basically. But we're confident we've got solutions. There are more naive solutions. So some of those look like basically if you pair off identical bits of hardware with identical system settings and identical, very well controlled framework settings, in many cases you can achieve determinism for the vast majority of operations. But then there's some harder problems that we're actively working on, but we're extremely, extremely confident we're going to solve.
Okay, fascinating. So another question that I've wondered about, especially when you're looking at training models on rented equipment, is the issue of privacy and the issue of making sure that your model is protected, because sometimes that is sort of um, the main asset, right? If let's say like a gaming startup wants to build a trained model, and then their model were to get out, they would lose all of the value that they're trying to create in some ways. And so, do you have solutions for that, or is that something that you're worried about when it comes to your protocol?
Yeah, this is a really interesting one because it's something that when we initially started going down this path with Gensyn, it was something we thought about a lot. Obviously, I'd been in the privacy space for quite a while, so it was kind of front of mind for me. And then Harry had intersected with a lot of data that couldn't get out and had like insurer specific provisions relating to it, so I had to think about it a lot. So it was one of our biggest sort of concerns with building a network like this. The way that we approached that as a concern was to just test it with end users. So we spoke to more than 200 essentially typical users of Gensyn or who would be users of Gensyn in the future. So that was like CTOs of like Series A tech startups that were doing machine learning, just ML engineers, ML researchers, a kind of broad swathe of people from in our network and from outside of it. And we tested the kind of the idea with them if people are familiar with the mom test, in the mom test way, which is where you don't ask very, very leading questions, which a lot of kind of early founders typically do, i.e., do you like this idea, versus I'm like, what do you think of this, or what problems do you have, and things like that. So we asked them essentially what would they would think about a network like we were describing and where any concerns would be. And privacy came out surprisingly low. So about 50% of them cared about privacy and said that that would be a blocker. And then we drilled into that. Of those 50% of them cared about model privacy. So 25% overall cared about keeping the model somehow secret, and 50% overall cared about keeping the data that they were training on somehow secret, which was really interesting to us because it basically gave us a roadmap of what we need to build. We can address 50% of the entire market with no privacy at all, with open models being trained on open data, kind of relatively in the open, and then we'd need to solve model data privacy, and then we'd need to solve model privacy. So that's what we've been doing. The first versions of Gensyn will be open, but open in the sense that the person that you send your computation to will be able to see that computation, but nobody else will. There's some really interesting techniques you can use to obfuscate and encrypt that data and that model. So the first kind of approaches we'll have once the initial Gensyn network is out are to use functional encryption, where you can actually turn the first layer of a neural network into a functional encryption key, which is homomorphic over the rest of the kind of network itself, which, long story short, and not getting too technical, means that you can train on ciphertext. So you encrypt the data on the submitter of the model's side, you send the model out, and you send the encrypted data out. It trains on the encrypted data. The person who's doing the work never sees the real data itself. They just see this model and the outputs, and then they send the results back. There's some downsides. You have to encrypt in order to use the model in the future. There's a slight performance hit. There are attacks that you can do. There's model poisoning, and there's kind of extraction techniques you can use on a model to find out about the data. But it's an approach that you can take. There's also some even simpler approaches around secret sharing and secure multi-party computation, split neural networks, and things where you just shard up the whole computation so that everyone gets a little piece of it. You can still do that with neural networks where you just split them all up. Everyone is training on a portion of the data. They don't know what portion it is. And then in order for them to extract it, they would all have to collude, which is something we're very familiar with in the crypto space around stopping that from happening. So it's not it's not an unforeseen problem, essentially. So yeah, there's lots of kind of techniques you can do with the data. And then model privacy is essentially only fully homomorphic encryption which can solve that, which is encrypted model, encrypted data, run a fully encrypted computation. But that's, for training, probably a few years away. Some people think forever away. We're more optimistic, given what we've seen the space progress, especially around zero knowledge proofs recently, that there's a lot of thought going into this space and there's a lot of things happening. And there's companies like Zama who are doing fully homomorphic encryption for model inference right now and doing it quite successfully. So it's a space that we watch very closely and we will incorporate into the network one day. But like I said, 50% of the kind of users don't really mind. We can expand on why. The big reason is everyone's training reference model architectures on open data sets right now. So the model architectures get published through archive or research journals and things like that. And the data sets are things like Wikitext or ImageNet or Flickr, where they're huge, curated, labeled open data sets that are required to get these models off the ground. And then when you do that training on a kind of secret data set, you do a little bit of fine tuning on that data set. It's easier to do that locally, and also we can do that encrypted with the data privacy portion. So yeah, there's weird aspects to it, but at the end of the day, the first 50% of the users don't mind too much, and we do have a roadmap for the rest of it. I don't know if you'd add anything to that, Harry.
I would just add that since we kind of, took this direction with our research, so around two and a bit years ago, it's been proven out with the kind of boom in open source AI. So I think it was more controversial to make these statements about 2 years ago, but now with things like Llama and Stable Diffusion, people are like, okay, there's state of the art image and text generative models, which are trained on open data to a large extent or entirely. So there's definitely been a push to the kind of open source side of the spectrum. I think there are forces out there which are trying to limit that open source nature in the machine learning space just now, which is very, very disappointing. But certainly, it's trending in that direction.
Okay, that makes sense. That's really interesting to learn that it's not that big of a deal, and also I'm happy to learn that. I think that I like the analogy of, Second Amendment kind of issues about that when it comes to AI, that we should all have access, right? Like that if there is
Mm,
that it's kind of like a right to self-defense or something like that. Like if only certain people have weapons, then you can't defend yourself, And if
yeah.
only certain people, if you think of AI in almost that same kind of way for the people that are scared of it, well, if the solution is to be able to have open source versions so that we all have access to them.
Yeah, I mean, let's be absolutely clear here. When people were talking about kind of disinformation and stuff like that, being the natural consequence of these models being in the hands of, for lack of a better word, the plebs, um, it's already been happening at the government level on an industrial scale for centuries. So it really doesn't feel like the kind of regulatory attempts to limit access to these models are coming from the place of protecting people. It's protecting people who are already kind of disseminating this information, which in most cases it comes from the kind of incumbent interests. Yeah, there's an interesting kind of question as well. As you said, it's like a 2A issue. It depends on, a lot of people take that and they extrapolate it to the idea of machine learning models are so dangerous to create an existential threat to society. But we would say that that belief is unfounded, not just unfounded. I mean, there's been no kind of event which you can point to which proves that it would just be a kind of extrapolation of current events. We think you should regulate the kind of infrastructure. Rather, you shouldn't regulate the infrastructure. You should regulate the app level. The same people who want
Mm.
to regulate kind of machine learning today are the same types of people who, if you put them in the early 1990s, would want to regulate the internet, because all the same stuff's true. It's easier to do terrible things using the internet as a substrate. Um, but I think unanimously the internet's been a positive force for humanity.
It just feels
Absolutely.
like technological conservatism again. Basically, it's this idea that a new technology comes along, it's a little bit new, therefore it's scary, it can do things maybe faster than we could do before, therefore we should stop it, or we should slow down progress in order to fully understand it, which just doesn't really make sense to us. And we should lean into that technology, but make sure it doesn't concentrate power in one entity's hands. And there's a really strange irony in some of the approaches to AI alignment and reducing bias in AI that essentially push it the other direction and mean that only a small number of people get to bias the AI. And it's doing that concentration of power again, because this technology is going to progress. It's going to come out. You can't hold it back. You try and kind of regulate it in that degree and you're going to push it underground. It's still going to be developed. It's still going to happen, but it's going to happen in secret from a small number of people instead of in the open from a large number of people, which is, I would say, pretty clearly from our perspective the better outcome, especially when it comes to the bias of models, because I think bias is a really interesting one that comes in with machine learning, because at the end of the day every machine learning model is inherently just a bias. It exists to be biased. And then we see kind of models coming out of like OpenAI and other places where certain cultures will be angry because the model is biased in a certain way, but models always will be biased. And instead of us trying to create these kind of like small number of as like evenly biased models as possible, why not just create loads of models?
Lobotomized.
And yeah, lobotomized models where it can only say specific vanilla things from one specific culture, which will inevitably conflict with other cultures in the world. Why not just let every culture make a model and you can use whichever model you want, instead of, yeah, we're all kind of trying to influence this one model, but increasingly weirdly. So instead of just training the model, now we're having to do it via a government who dictates what the company can train the model into doing. It just seems crazy.
Yeah,
I think for
absolutely.
us I was just going to say, for us, I think
Go
the
ahead.
ultimate end state is a universe where, firstly, models will become self-governing to an extent. They will have probably like an interspecies relationship with us, at least in kind of, my opinion, in the next sort of 10 to 15 years. They will require like a permissionless substrate they can live on. We live in this organic universe. In my opinion, they're going to live on a, permissionless compute network. So like a blockchain, where they can transact value and retrain themselves and get smarter, etc. The kind of question you have to have is around whether or not you think that someone training, those models today is inherently causing some enormous disaster like in the future. And I just really I struggle with the idea that people who are supporting a future where your computation's free are are yeah are putting society in harm's way.
Oh, wow. There's so many directions I could go right now. I had intended to ask you what you would say to the doomers, right? And I feel like you guys have kind of already answered that question here with what you just said. But the I guess I'm just curious, given all that you have said so far, what are your thoughts on AGI versus AI?
I think it's a really, I was going to say loaded term, but it's just a really undefined term. It means so many different things to so many different people, and it's hard to find a common definition so that we can actually discuss it. I think our definition might be different to other people's, and it obviously centers around like Gensyn in a way because that's our kind of vision of the future of AI. But it's like Harry alluded to. We think models will reach AGI when models are able to interact with the world and solve kind of their own problems without the input of a person. So the future we see is that kind of substrate of compute that Harry mentioned and a few other things, so that models have this environment that they can exist within without a human ever being involved. So a model can be deployed, it can train over the Gensyn infrastructure, it can access compute, which is its kind of fundamental resource. It needs that to exist essentially, and it can do that via a wallet where it has its own funds and via smart contracts where it can pay for things, and essentially kind of be live on that network. And then it needs the kind of model design, it needs access to the data and all of these things in order to be fully sort of independent of a human. And then once it is independent of a human in that way, that's AGI. And we have all of these models kind of existing on this substrate where they can't be turned off by any individual. The protocol can't be controlled by a centralized party. These models just exist, interact with each other, train themselves, trigger the training of other models, trigger the gathering of data, the gathering of expert knowledge, all of the resources that they need to exist. So AGI to us is this rich ecosystem of models, all kind of existing as humans do, essentially, within an environment. And that environment fundamentally is underpinned by crypto technologies, and cryptocurrency as a sort of financial technology, Gensyn as a compute technology, another protocol for data, another protocol for the expert knowledge to design the models, and then they're kind of self-sufficient.
Yeah, I'd
Okay.
also add that it's not uncommon for this in this world that we're kind of painting. You've got lots of different models which are all autonomous, and you kind of close out bias in the world by having lots of a meta model which can connect together lots of sub networks which have the bias that you like or whatever, the kind of the voice you want to hear. I think it's funny because we see this throughout life in the kind of physical world all the time. The best example is if you send your kids to a certain school. If you send them to a school which has certain values, or you want them to like associate with certain clubs, etc., you're kind of instilling this like set of values, and you care what the kind of teachers are saying to your kids. Like there's certain ideas that you want promoted. I'm sure that no one listening to this would want their kids to be in a classroom in North Korea or something like that. But within the skept within the kind of scale of your viewers, there will be a huge disparity. If you think about how educational machine learning can be, so much so much can be learned just from using ChatGPT as a tutor. I hazard it's better than a large percentage of like kind of public school teachers in many developed countries today. at teaching very advanced, like niche subjects. You know, if you want to add in a bias there, which teaches it in a certain way, as a parent, you should be able to do that. In the same way that you should have the ability to choose a school that you send your child to. But you wouldn't be able to get that in this kind of government sanctioned, this is the curriculum, it reads like this, it must look like this, your kids can only learn these things. If you learn these other things, it's illegal. So yeah, that's the world that we kind of see and can be unlocked by these models.
Okay,
Quick
great.
book recommendations. Sorry to interrupt. Quick book
No.
recommendation there. The Diamond Age by Neil Stephenson, for thoughts around AI teaching people, being this companion that we learn from. Like, the fact that it was written so long ago is insane to me, because it's so on point. So yeah, highly recommend that book to anyone listening.
Neil Stephenson also wrote Snow Crash, of course, which everybody in crypto already knows. But yes, awesome.
Yep.
Great recommendation. So, what I think is so fascinating about these worlds that you painted is that for the doomers in the sort of Skynet world, that would be if we continue down the path of something like open AI being the only allowable AI that we are kind of having to train and use, and has this one particular bias, and that there's just this kind of like one AI to rule them all, and that would be a much more dangerous scenario, I think, than the one that you're painting, where we have rather AGI, we've made the leap now to where it has whatever this missing link is that makes it go from just AI to AGI. When we have this world of many, many AGIs that you can kind of like pick your flavor and you can kind of connect them, in some ways, the humans are still in more control in that world, or it's at least more of a peer relationship than over here, where there's sort of like a hierarchy of folks that can kind of control what's available to us, what is acceptable thought or acceptable information, versus over here where all information is available and it's up to us to interact with it as we see fit. Would you guys agree with that kind of
Yeah.
picture?
I think crucially it's visible in the world that we describe, because at the end of the day, markets and incentives are kind of what govern a lot of what happens when we do things collectively. And the development of these models, it requires a lot of fundamental resources that have to be paid for. So markets do govern, markets and incentives of parties do govern the development of these models. We can either allow that to continue happening in the shadowy way that it's happened for a very long time, which is where governments get involved and companies are incentivized to lobby for certain controls by governments, because then it gives them monopolies over areas and things like that. We can let that happen in secret and behind closed doors, or we can do it openly through a protocol that everyone can see, similar to how we did with currencies, with cryptocurrencies in general. They're open but secured by all of us together. We'd like the same thing to happen for the resources that underpin possibly the greatest new technology since the last industrial revolution, essentially. And we think it's crazy that you wouldn't build it in that way, that we'd continue to choose the shadowy behind closed doors way rather than this new way that we now have access to with a technology that didn't exist before. It's a no-brainer to us.
Yeah, I think that there's two things I want to talk about before we have to close out today, which is the regulatory capture part that you're leading to right now, where a large company says, well, here's the regulation that we need, but they're outlining regulation that they could easily comply with, but that young early stage companies absolutely couldn't compete with, right? There's that aspect of it. But then there's also the crypto aspect of it. Does Gensyn have some sort of crypto token native to its infrastructure, or is that on the roadmap? How does that work for you guys?
So on the first point, the idea of there being regulatory capture, it definitely is regulatory capture. And the same with the GDPR, the fines are catastrophic if you're a small company, but if you're Facebook, they're like priced in to the stock price that you're gonna get these fines. So we definitely see a kind of similar point there. It also, there's a more kind of like Orwellian side to it, where if you think that for a long time we haven't let people regulate our own minds, our own kind of, you have the freedom of thought. You're allowed to think things. Your biological neurons are safe. Very soon, we're going to be augmenting that with artificial neurons. And the fact that those neurons, in brain machine interfaces, wherever, are going to be kind of captured in regulation from,
God, that's
the
terrifying
European
thought.
the European Union or elsewhere is pretty yeah, pretty sad. Like, I don't know, it feels to me like when you look forward 15 years, it looks like a bad idea to have this top-down regulation. It doesn't mean at the application level there shouldn't be, though, and this is the kind of clear distinction, right? On the infrastructure level, when you talk about like, can you physically kind of connect together, I see, like, in your background, for maybe people kind of listening to this can't see it, but like the ARPANET diagram, right, from the 70s, like that, is an example of this peer-to-peer connections, happening on an infrastructure level. I think everyone's cool with that. That should be fine. That's where they're trying to regulate AI now, like, at the infrastructure level. At the application level, if there's ever going to be regulation, it should be up there, right? So if you're,
Well, and just
you
to
know,
close the
yeah,
loop in that argument, the reason for that thinking, because I agree with you on this, is that the people should be held accountable for their actions. And so it's at the application level that the people are involved, right? Like that the application is the one where there's somebody who's serving this to end users, or who's providing some sort of service or something like that. And so that's why the application level is this sort of filter, and thus should
exactly.
be the regulated party,
Yeah, it's like, you can buy a knife, and you can use that to cause harm, or you can use it to, like, cook a steak, right? And like
Mhm.
the kind of, you're not regulating the knife, but if you hurt someone with the knife, then that falls into the scope of regulation. That's the idea. You train an LLM that can be used for good things as determined by society, or bad things. It's the use of it which should be regulated, if at all, not the kind of construction and kind of building and ownership of it.
Yep. Yep, that absolutely makes sense. And then to get into the second part of it, which was the crypto question. So does Gensyn have a token of some sort? How does crypto come into play in your protocol?
So we will have a token. We don't have a token yet, and it's very much a technical detail to us. So crypto as a technology, it's an enabling technology to build what we've described here, essentially, to take away that need for a centralized party to make certain decisions and to check work and things like that. In order to take that away, you have to have lots of technology that's kind of at the machine learning level. It does cryptographic checks and game theoretic checks and things, but you also have to coordinate a lot of parties who have different incentives. So there's a big game theoretic challenge over the coordination of those people, and that can be solved via some of the like cryptocurrency technologies. So you require somebody to stake a bond in order to provide their services as a compute supplier. And then when they're doing the work, if malicious behavior is detected by other parties, then that bond can be sacrificed to pay out other parties. You end up with redundancy in the protocol there, where you could keep chaining the sacrifice of a bond when somebody hasn't done the work correctly, which pays for somebody else to do the work, but then their bond could be sacrificed, and the whole thing eventually settles out. But what you get there is tons of micropayments that all settle out at the end with loads of different parties involved, which if you try and do that purely technologically with our existing like fiat payment system, it'll be an absolute nightmare / impossible. So
Slash
you,
impossible.
so you have to have some programmatic currency underneath it. You could do this with a stable coin, interestingly, so you could still have the same kind of payment infrastructure in there, but with a stable coin you would lose that kind of like currency that underpins only machine learning work and is only used for machine learning work. You'd also have to use a lot of the infrastructure that already exists for access to those stable coins. So you'd be reliant on the protocol. One of the difficulties with building something like Gensyn is eventually you have to terminate things on chain. So the chain is our source of truth, basically. It's where we get trust from. So everything that we do to coordinate parties off chain eventually has to get back to the chain, and then the chain will perform certain computations, which is just lots of people performing that computation to settle things out. We want as much freedom as we can have in the computations that chain performs, which means that we're building our own chain. So rather than be at the kind of limitations of the EVM OEM and Solidity, where we would be able to do them, but we'd have to change what we can do, and it'd have to be very specific. We'd have to work within the language. We're building as a layer one protocol. We use Rust, so basically whatever we can do in Rust or WASM, we can do on our chain. That's really nice for us, but it necessitates us creating our own kind of native currency. And then from there, you end up with a currency that essentially tracks machine learning training work around the world. The kind of end goal of Gensyn is that Gensyn represents all of the kind of machine learning work that's done in the world. All of that training computation is represented within the currency. But we very much won't launch the currency until we need it technically, because we don't want to kind of go through any of the speculative nonsense that a lot of projects have to go through. We prefer to just build a technology and then release it as a technology, essentially.
That's understandable. It can be, I think, highly stressful for projects when they have a token out there while they're still actively building, because there becomes so much noise about the token price, which is just an unfortunate aspect of the industry and where things stand. So is Gensyn based in the US?
So we are technically based in the UK, but we have a US entity. But yeah, we're a UK company. We started in London. We now have one employee, I think, in the UK, and the rest are all over. We hire fully remotely. Many open positions. If anyone's interested in listening, please do get in touch and check out the website. But yeah, at the moment we've got people all over Central Europe and the US out to the West Coast. That's kind of where we like to hire from. Otherwise, time zones just get really, really difficult.
Yeah, for sure. So I was asking because I was wondering if the not wanting noise about your token price totally makes sense, but is regulation an aspect also that's held you back from launching the token? Like, is that another aspect that you're waiting on, or is it just a purely technical question for you guys?
Purely technical. I mean, the regulatory stuff, the kind of environment in the US has been quite hostile, for sure, or at least quite kind of opaque. The kind of thinking from our side is just really what Ben said. We'll only launch it when we need it, and we'll only need it when the network's ready for a release. So we don't kind of think about. We hope by that time there's definitely some sensible policy from governments on it, which in many cases would be just to not be involved at all, in my opinion, at least. So, but yeah, we'll wait and see.
Okay.
Just on as a final point on that, I think it's partly influenced by the regulatory kind of landscape, because it's so grey for a project like ours. We are very clear what we want to build. We've been very clear what we're building for years now. We don't want to hide anything. We're not trying to do anything misleading. We just want to build this technology that we talk about. And there's no clear way for us to kind of indicate that ahead of time and not worry that at some point in the future regulation might come in that will detrimentally affect us. So our approach is to just be as vanilla as possible and just say, we're only going to do this when we absolutely have to, when we need it technically. Outside of that, that's all we're doing. We're just being very, very straightforward. And it seems to be the only way to navigate a grey environment, like a grey regulatory environment, is to just be really boring. So that's what we do. That's our approach, basically.
Yeah, it's super tough right now, and it's having a really negative impact on the industry as a whole. It's kind of like selecting for people who are willing to take that much risk or are nefarious, instead of selecting for founders like you who just want to build cool stuff. There's enough risk being a startup founder without this like looming threat of some sort of prosecution happening years down the line, right? For stuff that you did in the past. It's absolutely crazy. I
Totally.
wish I could talk to you guys for another hour. This has been such a fun conversation. You have such an interesting project. Where can people find you?
We're on Twitter at GensynAI, and at Fenbuilding and at _Grieve for the personal ones. Our website's Gensyn.ai. I don't think we're anywhere else notable. It's probably the main places. There's a jobs
Yeah.
page on our website, which is probably where we'd ask people to go, because we're hiring a lot of people right now.
Yeah.
Okay, awesome. The final question is the name of our series. What kind of internet do you want?
A decentralized one, one where power doesn't accrue to small numbers of entities who have outsized impact, one where everyone can build these things.
Harry?
I want one which, broadly approximates nature. So it doesn't have kind of artificial constraints imposed on
it. Cool answer. Thanks so much, guys, for the time. Really appreciate it. Have a great rest of your day. Thanks, everyone.
Thank you.
See you next time.